I want to start this video. We're going to talk about extracting square roots. This is your very first listening guide for this section for the next class. So we're going to solve equations by the square root property. That's basically just taking the square root of both sides. So if we go over this process, if x squared equal k, any number, then to solve it, the square root of x squared, to back it out, I would just take the square root to make it an x to the first power. So that's what we're doing. You just don't really see it, but that's what we're doing. So take the square root of x squared, we'll look at it like this. Extracting square roots from both sides. So you're going to take the square root of each one of these, and the square root of x squared is x. The square root of 25 is a 5, but it's also the opposite of the square root of 25, or negative 5. And I'll show you why. Because 5 times 5 equals 25. Isn't that the same thing as 5 squared? But also negative 5 squared equals 25. Or negative 5 times negative 5 equals positive 25. So we have to remember that. Also remember that all quadratic equations have two solutions, don't they? So the positive and the negative solution would count as your two solutions. You can also write the plus or the minus in front of it, positive 5 or negative 5. I'll take either one. Just something to show me that you know there are two solutions. So if we follow the rule again, and this worked out perfectly because 25 is a perfect square, but they're not all perfect squares. If we take the square root of both sides again, then according to this square root property, I have x equal positive 13. And I also have x equal the opposite of the square root of 13. Now, I don't know if you realize this, but if you played on your calculator and you wanted to find the square root of a number, the square root sign is right here, this in blue. So you can find it by hitting the blue key and the square root sign and then sticking 13 under there. Well, this shows you that 13 is not a perfect square. I don't want this answer. I would rather have the radical form, but this shows you that you can leave 13 under the radical, as opposed to this one. The square root of 25 is a perfect number, or a good whole number is 5. So this would suffice as your solution. Also, a point to remember, both of these, negative 5 squared is positive, isn't it? And positive 5 squared is positive. That means signs, like signs, will always be positive. So know that there's no solution to take the square root of a negative number. You can't. You just can't do it. So that one, in this case, would be no solution. Now, what if these numbers were not perfect squares, like 25, or 9, or 4, or 16? These are not perfect squares. So we need to play with this, and I'll show you how to find that. First, let's just follow the rule. X would equal square root of 12. X equal opposite the square root of 12. Well, 12 can be what we called reduced. A square root. Now, 13 couldn't because that's a prime number. It's just 1 times 13 is 13. But 12 can be broken down into its prime factorization. You could look at it this way. square root of 12 is the same thing as 4 times 3? Can 4 be broken down into a perfect square? That is a perfect square. So the square root of 4 is 2. So that pops out. And 2 square root of 3 would be the radical form of square root of 12. So 2 square root of 3. See, the 3 stayed under the radical because we didn't take a square root of it. We just took the square root of 4. X equal opposite 2 square root of 3. There's your 2 solutions. Let's do it for 27. And I can show you another way to do it. Suppose you don't remember that 12 breaks down into 4 times 3 and 4 is a perfect square. Suppose you don't know that. So do what we call a prime factorization. That always works. Factorization. Just break it down into primes. For instance, if we had 12, that's the same thing as 2 times 6, and 6 is the same thing as 2 times 3. So those are all prime numbers. So square root of 12 is the same thing as 2 times 2 times 3. Anything you have a pair of, put it to the outside, and you get the same answer. So you can think of it either way. You might need to practice it though. X squared equal 27. Well, I know if it's got x squared equal, it's going to fall under my square root property. That's how you know the approach to that problem. X equals square root of 27, or x equal opposite square root of 27. Now you just need to know, can you break it down? Let's see. 27 would be 3 times 9. And then 9 can be broken down into 3 times 3. So you want to take the square root of it, take a pair out, and the long number stays under the radical. So it can be broken down. 3 square root of 3 or negative 3 square root of 3. And those are your solutions. Or you could write it plus or minus 3 square root of 3. That would be fine. Right here, same thing. And we're just practicing these numbers that can be broken down. You learned this back in Algebra 1 or even pre-algebra, but I just wanted to go back over it again. X equals square root of 32, or x equal opposite square root of 32. Now I got to see if I can break it down. 2 times 16, 2 times 8, 2 times 4, and then 2 times 2. Gracious. All 2s, isn't it? 1, 2, 3, 4, 5. So the square root of 5 2s, that's a pair, that's a pair, and then the single one. And 2 times 2 is 4. So x equal 4 square root of 2, and x equal the opposite of 4 square root of 2 would be your solution. So you may want to practice these a few times. Now the only difference in these and these up here, they've just got a number inside the parentheses that's also squared. Follow the same process. Don't make it hard. If everything is squared, then break it out of the squared. And x minus 4 equal the opposite of the square root of 12. Same process, except you need to keep going and have just x on one side of the equal sign. So you can add your 4 to both sides, then you're going to break down your radical. Add 4 to both sides and then break down your radical. I think we figured out already that 12 is the same thing as 2 square root of 3. So x would equal 2 square root of 3 plus 4. And from this side, x would equal negative 2 square root of 3 plus 4. See if you can do this one. Pause it and then look at it and see if you got it right. So I follow my square root property without doing anything. And then I get x by itself. And then put the square root of 24 in reduced terms. So let me go down here and get the prime factorization. So 3 times 8, and then 8 is 2 times 4, and 4 is 2 times 2. So the prime factorization of 24 would be 3 2's and a 3. And do I have any pairs? Yes, I got a 2. So x would be 2 square root of 6 plus 8. And x is negative 2 square root of 6 plus 8. That's extracting square property, or extracting square roots property. So see if you can do that on your own and be ready for class. At least go over practicing these square roots, because we'll practice it some more.